This video is going to talk through skill number 10, solving rational equations by using the LCD method. And in this particular video, all of the denominators are going to be polynomials quadratics. So looking at the first example, see that my common denominator is x squared minus 4, the difference of squares. Let the camera get back into focus. Okay, so my common denominator here is going to be x plus 2, x minus 2. Which means that my domain restrictions are going to be positive and negative 2. So this is my LCD and my domain restrictions. So I'm going to solve this by the LCD method, which means I'm going to bracket the entire equation, and I'm now going to multiply by my common denominator over 1. When I multiply the first ratio by the common denominator over 1, x minus 2 is going to divide out of the problem, and what's going to remain is my original numerator, and my original numerator is going to be multiplied by the factor that was missing in its denominator. So here that's going to be x plus 2. Moving on to the second ratio already has the common denominator, so the only thing that's going to remain standing is his numerator of x plus 2. And then moving to the last piece, I'm simply going to multiply 1 by the LCD, and now when I write my LCD, I'm going to go ahead and write it as a product. So I just want to review. We've worked with this basic skill, but this would be the maximum amount of clutter that we would have in an Algebra 1 course. So what I've done, I'm simply multiplying each ratio by that common denominator over 1, and then what's going to remain when I do the multiplication in 3 different spots, the factor that was missing from the denominator is going to remain in the problem multiplied by the original numerator. And now I'm just simply going to clean this up, 2x squared, moving on across, and then gathering all like terms. Let's see, I'm going to have plus x, that's 6, and then I'm going to bring 4 over, and that is going to give me, let's see, that's 4x, that's where my mistake is, 4x, and that's actually going to be, hold on for a second, I made a mistake. This is going to be x squared plus 5x, I'm going to add the 4 to both sides, plus 6 equals 3. So I made a little mistake right here, forgot to copy my x. Okay, now this is going to result in a quadratic to be factored. So I'm going to factor this as x plus 3 times x plus 2, setting that equal to 0. So my two roots or solutions are going to be negative 3 and negative 2. And now when I'm solving a rational equation, I have to go back and compare my solution set to the excluded values or the domain restrictions. And you can see that I have positive 2 as a root, and positive 2 is also part of the excluded values set. So positive 2 is going to be considered an extraneous root. So an extraneous root is a root to the original equation that's also a member of the excluded values set, or it's a root to the original equation that's not allowed to be part of the solution set because it makes the equation undefined. And I'm only going to have one solution for this particular problem. The only solution is going to be x equaling negative 3. So this would be the only solution for this particular problem. Okay, let's move on to do the next example. So here once again, I've chosen a little example for learning with the difference of squares. So my common denominator is going to be x plus 3 times x minus 3. And my domain restrictions are going to be positive and negative 3. So these are my domain restrictions, my excluded values, however you choose to see it. And when you're solving rational equations and you have excluded values, you always have to check for extraneous roots. And let's go ahead and get through the problem. So once again, I'm going to bracket the entire problem. I'm going to multiply by that common denominator, and I'll look at it in its factored pieces so that it's easy for me to see what's happening. The first ratio has the common denominator, so the numerator is the only piece that's left standing. This is a subtraction problem. X plus 3 is going to divide out of the problem, and what's going to remain is that original numerator and the factor that was originally missing. And then I'm going to set this equal to x squared minus 9, and I'm going to go ahead and put this in its multiplied form because I have to re-simplify this whole problem and gather like terms. So it's just making my job, just giving me more steps if I write this in its factored form. So now cleaning this up, I've got the quadratic terms. I like to keep my lead coefficient positive, so I'm going to add x squared to the other side. And let's see, cleaning this up, that's going to give me 2x squared, and that's going to be positive 4x, which means it's going to be negative 4x on the other side, and then negative 9 subtracting 7. And let me check my work to make sure that I've done that correctly. Yes, that's correct. And I see that I have a GCF of 2. So when I remove my GCF, I think the factoring becomes pretty easy here. And I'm going to end up with x minus 4, x plus 2. So my two roots or solutions for this particular problem are going to be positive 4 and negative 2. These are my roots, positive 4, negative 2. At the end of the problem, I need to go back and compare. And let's see, I don't have everything on the screen, but it's easy enough to fix that. X is not allowed to equal positive or negative 3. I'm going to compare my solution set to my excluded value set to see if I have any overlap or controversy, and I don't. So this would be the completed solution set right here. There are no extraneous roots. I have no conflict between my solution set and my excluded values. Okay, let's move on. Let's do the next problem. Problem number 9. And here my common denominator, the two denominators that are given are actually the factors of the third denominator. So this is going to be my LCD, x plus 2, x minus 5, and my two excluded values are negative 2 and positive 5. So let's go ahead and carry on with the process. I'm going to multiply both members, or all three members, by that common denominator over 1. And the first multiplication, x plus 2 is going to divide out of the problem. The original numerator is going to remain, and it's going to become multiplied by x minus 5. So moving across, x minus 5 divides out of the problem, and what remains is the original numerator multiplied by the factor that was missing. And the third expression already has that common denominator, so I'm just going to set it equal to its numerator of 14. So this is what I'm working with to clean this up, distribute my x's, clean it up, and then refactor. And cleaning all this up, I'm going to end up with x squared plus 2x, setting that equal to 0. This is just simply GCF factoring. So my two solutions, 0 and negative 2. And once again, I compare my solution set to my excluded value set. And I see that in this particular problem, I have an overlap. Negative 2 is not allowed to be a solution because negative 2 is an excluded value. So negative 2 is what I would call an extraneous root. And I would only have one solution to this problem. X equaling 0 is my only solution. And let's do the last example together, number 10. Let's see, number 10. All right, I've got a difference of squares, and I've got this differing by -1. So I'm going to go ahead and list my common denominator as x plus 2, x minus 2. My domain restrictions are positive and -2. And I'm going to clean this up just a little bit before I get started with the problem. So I'm going to take this problem and I'm just going to recopy it as it is for just a minute. And I'm going to turn this into a subtraction problem so that I can deal with that differing by -1 portion. And this is the problem that I'm going to work with, just trying to clean things up as much as possible before I get started. So I'm now going to bracket the entire equation, and I'm going to multiply it by that common denominator over 1. The first ratio already has the common denominator, so the numerator is the only piece left standing. The second ratio has x minus 2 dividing out, so I'm going to be left with an x and an x plus 2. And then the last ratio, x plus 2, divides out, so I'm left with the current numerator and the missing factor from the denominator. So now I'm just going to clean everything up. Gather like terms. The quadratic terms are going to divide out of the problem, and I'm going to be left with, they're both on the same side, so I'm going to be left with 4 minus 2x and 2x minus 4, which almost looks like an identity, but it's not. I'm going to gather all of my x's on one side and move the constants to the other side. So I see that x equals positive 2. So in this particular problem, I now am going to compare my solution set to my excluded values. So here are my excluded values. Here's my solution set. So I see that I have one solution, but the solution that I have is also an excluded value. So this is a case where I would say that this particular equation has no solution. It has no solution because its only solution is an excluded value.